The previous videos on area looked at triangles, quadrilaterals, circles and sectors of circles. This video looks at surface area of solids, that's three-dimensional shapes such as cube, cuboid, triangular prism. This is a composite shape, so it's a prism. Prisms have a shape which is on the end face that continues all the way through the shape to the other end. Here, cylinder is a circular prism. This circle continues all the way up the shape to the top. There's a pentagonal prism. The end face is a pentagon. This is a regular pentagon. All the sides of the pentagon are equal. If the shape is the end face gets proportionally smaller as it goes up the shape till it comes to a point, that's a pyramid, square-based pyramid here. Cone is a circular pyramid. This is a pentagonal-based pyramid. They match what's up above them. So, three-dimensional shapes. The faces can be rectangles, triangles, circles, parts of circles. So, the area calculations of previous videos are involved. First one here is a pentagonal prism, pentagon on the end. If you think of what the net would look like, that's the net of a pentagonal prism. It comes together like that. So each face on the side here was a rectangle, but the end faces were pentagons. So you've got areas of rectangles and areas of pentagons, which are going to be given in the question, as you see. So the area of the end face here is 90. Same with the top, of course, because that shape, pentagon shape, continues all the way up the prism. So if you look at the net, it's got 5 rectangles and the 2 pentagons, which are area 90. This edge here is 6 and the height is 10, so each rectangle is 10 by 6. That makes the area 60 for a rectangle, and there are simply 5 of them, and 2 90s. So you get 5 rectangles area 60 and 2 pentagons area 90. The total area is 480 square centimetres. So 3D shape here, that's the net. The area of the net is the surface area of the 3D shape. Another example, triangular prism. End face is a triangle, in this case a right angled triangle. The other faces are rectangles. The yellow face on the bottom is a 10 by 15 rectangle. The sloping right hand side is 8 by 15 and the sloping left hand side is 6 by 15. So that's a triangular prism. There's the net. There's a yellow face, 10 by 15. There's a right sloping side 8 by 15 and the left sloping side 6 by 15. And the triangles, which are 6 by 8 by 10, could attach on side 6 here, or they could have been attached on side 8, or the hypotenuse could have been placed along side 10. You've got 3 rectangles, 2 triangles. Triangles are half base times height, 6 times 8, but you double it. 6 times 8 and half, but you double it because there's 2 of them. So it's effectively, the triangles are 6 times 8 for the 2 of them. So these are the sizes, 8 by 15, 10 by 15, 6 by 15 rectangles. Triangles, 6 times 8 divided by 2 and double it. Add these up and you get the surface area. So that's a triangular prism. Rectangles and triangles. Cone. It's a wee bit more awkward. So here's the cone. The orange circle is the base here, and there's a curved surface which is blue. There's a radius which is on the base, the radius of the orange circle. Then there's the height of the whole cone, and importantly the sloping edge, the hypotenuse of the triangle. So there's a right angle triangle there, the hypotenuse of the triangle, a sloping edge, that becomes, as it opens up, the radius of this sector So this is a sector of a bigger circle than this one. So this is radius R, if you like. This is a sloping edge, which we call sloping S. That's a radius S. So this is a sloping edge, and it's a radius of a sector. So the curved surface, this red dotted line is the sloping height. It's 12. It becomes the radius of the sector. And there's a circle on the bottom, that'll be the base. So curved surface, that sloping edge 12 becomes the radius of the sector. And importantly, that blue circumference has become that edge here. That arc is from the circumference. So the circumference, pi d, pi times 4, radius 2, diameter 4, pi times d, this circumference on the base becomes this arc length. So that arc length is 4 pi in this case. From the 12 and from that 4 pi here, you can work that out to be 60 degrees doing the work in sectors from the last video. However, the worksheet, which will involve these cones, it will have the angle there in the question. It will show you the net and it will show you that angle, but it can be worked out from the 12 and the 2. The worksheet can be accessed by the link in the description. I'll have the questions and I'll have the answers with it. So we've got a curved surface, radius 12, and this angle is 60 degrees. From that, using the work of the last video in sectors, you can work out the area. 60 degrees is a sixth of the circle, radius 12. So pi r squared, r's 12, 144 pi for the whole circle, 60 degrees, that's a sixth of the circle, 60 degrees out of 360. So you want a sixth of that, you divide it by 6, that area, curved surface area, is 24 pi. The base is a circle radius 2, so that's simply pi r squared with r being 2, it's 4 pi. So the total surface is the curved surface plus this circle, which gives you 28 pi square centimetres. So the exact answer is 28 pi. So that's a cone, a sector of a circle for the curved surface and the circle on the bottom. Next is the cylinder. If you take a cylinder and break it down into its net, it's 2 circles, top and bottom, and the curved surface actually becomes a rectangle area pi dh, where d is the diameter and h is the height of the cylinder. To show that that's the case, go to cylinder here, radius r for the circle, height h. If you watch how it breaks up, there's the circle coming off radius r, so the area is pi r squared. As you slice open the curved surface and open it out, that's like a label coming off a can. Watch the top circle, you can see that the circumference fits along the edge of that rectangle. So that rectangle has a length, the circumference of the circle, pi d. So the rectangle's length pi d, breadth h, so its area's length times breadth, pi d times h, pi dh. So that's where the pi dh comes in. It's illustrated here, that's the blue circumference. It becomes the length of the rectangle. Pi d is the length of the rectangle and its breadth is the height. So that's like the label coming off a can. Its area, pi dh for the curved surface, and then it's got the flat surfaces, top and bottom, pi r squared. So when you're looking at a cylinder, the total surface area is the curved surface pi dh plus the 2 circles of pi r squared each. When you're asked questions on cylinders, it could be that it's got closed ends. That means it includes the two circles like a tin can. It could be open top, that is, it's just got a circle in the bottom, but none in the top like a waste paper can of some sort, or an opened up can. If you open up a can, take the lid off, that's an open top, or it's open at one end. If it's open at both ends, that's like a pipe. It's got no circles at all. It's just the curved surface. So that's like open-ended, no circles, a pipe. So curved surface is pi dh. So here, diameter's 10, height's 15. Just put the figures in. Left it exact, so it's 150 pi. Pi r squared for the bottom. Radius is half that 10. Radius is 5, so it's pi times 5 times 5 is 25 pi. So that's the pi r squared. And if it's got closed ends, you've got pi dh and 2 pi r squares to put in. And that comes out at 200 pi square centimetres. If it's open top, it's only got one circle, pi r squared. So you've got 150 pi and then one lot of 25 pi. If it's open-ended, you just get no pi r squareds. It's only pi dh. So it's just the 150. So that's the three cases, whether it's closed, open top, or open at both ends. That is, there's no circles. So that's the surface area of a cylinder. Also could be asked, pyramid, as you know, a pyramid will break down into triangles. And it's worth pointing out here, this has been looked at in the trigonometry and Pythagoras videos. You've got the height of a pyramid, you've got half a side here, and you've got a sloping line here, and it makes up a right angled triangle. That was looked at in Pythagoras and in trigonometry because it involved right angled triangles. This sloping side here with a line on it is one of the sides. This red dotted line is the height of the triangle. So half base times height. Base is one side of the square, and the height is that dotted line which is going down the middle of this side. So triangles and a square. I haven't got an example on these, but the things you've looked at, they'll be on a worksheet which you can access if you click the link in the description. Also, composite shapes. So here we've got half a cylinder on the top and a cuboid on the bottom. So that's the end face. It's a prism because that shape continues all the way through from one end to another. So you've got rectangles which are like the 4x15 on the bottom, but you don't have one on the top because it's inside the shape, it's not part of the surface. You've got on the left a 4x10 and on the right a 4x10, and in the front a 10x15 and in the back a 10x15. So you've got these sizes of rectangles, but only one of the 4x15s. So you put that together, you've got one 4x15 and two of each of the others. The total area of rectangle is 440. You then get two semicircles, so that makes a whole circle. So for the semicircles, two of them go together to make one whole circle, diameter 4, so radius 2. So pi r squared becomes pi times 2, left is 4 pi to keep it exact. The curved surface is a half of pi dh because it's half a cylinder. So the h is a 15 here, the length. The d is the 10, the d is the 4, same as the 4 at the bottom. So that's the diameter. So diameter 4, h is 15, and you half it because it's only half a curved surface. So you put the figures in, you've got the d4, h15, and you half it, it comes out 30 pi. So your total surface is the 440 for the rectangles, 4 pi for two semicircles, and 30 pi for the curved surface, half a cylinder's curved surface. Put them all together, that's the total surface area. Exactly, it's 34 pi plus 440. If you put that in the calculator and worked it out, it'll round to 547 square centimetres to three significant figures. So that's a composite shapes. The worksheet will have total surface area of the cylinders, so that includes the two ends. It's got pyramid that I mentioned, so it's showing you that sloping edge is 12. Triangular prism, pentagonal prism, and this composite. When you download the worksheet, it'll have the answers with it. Cones are a bit trickier, so there's a cone there and it shows you the angle in the sector that's involved. As I say, it could be worked out from the 16 and the 4 that would be 90 degrees. It's simply that the radius is a quarter of the sloping height, so it's a quarter of a circle. Here, the radius is a sixth of the slope, so it's a sixth of the circle. So, answers will be with them. They'll be on the sheet, and you can download it using the link description. So there are 4 cones here. So there's the worksheet, 12 questions, the answers are with them using a link in the description, and also from the same link, the notes for all the videos on area, right up to the surface area there. Concentrating on the cylinder. Hope you found the videos useful.